Hi everyone. Today we're going to study evaluate limits involving infinity, and this is part 2. In this video, we're going to evaluate the limit of a rational function that is of this form. The limit of f of x over g of x as x approaches infinity. The rule is we're going to divide both the numerator and the denominator by the highest power of x in the denominator. Then simplify. Let us see this example 1. Evaluate the limit of 5x squared plus 8x minus 3 over 3x squared plus 2 as x approaches infinity. Let us copy again this problem down here, and as the rule, we're going to divide both the numerator and the denominator by the highest power of x in the denominator. We can see here that the highest power in the denominator is x squared. It means we're going to divide each term of the numerator and the denominator by x squared. So we will have like this. And then let us simplify some of the fractions. We can cancel some terms that we can cancel. And let us write the simplified expression. So the new fraction will be 5 plus 8 over x minus 3 over x squared all over 3 plus 2 over x squared. And from here, we're going to show that we are going to take the limit of each of the terms in the numerator and in the denominator respectively. So it will be like this. Now let us observe that some of the limits have constant in the numerator. We're going to pull out that constant that is to be multiplied by the limit of the respective function. So this will be the next step. Some of the limit here are considered to be approaching 0. Now let us simplify the limits of respective terms. So the limit of 5 as x approaches infinity is simply 5 plus this one here becomes 8 times 0 minus 3 times 0 all over the limit of the constant 3 as x approaches infinity is the constant 3 plus 2 times 0. Simplifying further, this 8 times 0, 3 times 0, and 2 times 0 are all equal to 0. And simplifying now, we have 5 over 3. This is our final answer. Let us see example 2. Evaluate the limit of the function 11x plus 2 over 2x cubed minus 1 as x approaches infinity. Let us rewrite our problem down here. And as the rule says, let us divide both the numerator and the denominator by the highest power of x in the denominator. Let us observe that we have the x cubed as the highest power in the denominator. So we are going to divide each term of the numerator and the denominator by x cubed. So we will have this expression now. And then let us cancel some terms that can be cancelled. And let us rewrite the new expression to be like this. From here, let us show that we are going to take the limit of each of the terms of the numerator and the denominator respectively. So this is how it will look like. Some of the limits have constant in the numerator, so we can pull it out to show that we will multiply that constant after taking the limit of the function respectively. And then we can simplify some limits that will be equal to 0. Now let us evaluate the corresponding limits to be like this. 11 times 0 plus 2 times 0 all over the limit of 2 as x approaches infinity is equal to 2 minus 0. Simplifying further, 11 times 0 plus 2 times 0 will be 0 plus 0 all over the 2 minus 0 is simply 2. And this is equal to 0 over 2, and the quotient is simply 0. This is our final answer. Let us see this example 3. In here, we have problems A and B. The problem A is the limit of the function negative 4x raised to 4 plus 7x all over 2x squared minus 3x minus 10 as x approaches positive infinity. For problem B, it will be the same function, but this one is x approaches negative infinity. Let us begin with problem A. The rule says, let us divide both the numerator and the denominator by the highest power of x in the denominator. So we see here that the highest power is x squared. So we are going to divide each term of the numerator and denominator by x squared. So it will be like this. And then let us cancel some terms that can be cancelled. Let us rewrite the simplified form of the expression. So we have now the limit of negative 4x squared plus 7 over x all over 2 minus 3 over x minus 10 over x squared. And then let us show that we're going to take the limit of each of the terms in the numerator and denominator respectively. So we have now this expression. We can observe also that some limits have constant in the numerator. So we're going to pull out those constants and then multiply by the limit of the function. So it will be like this. For example, this limit of 7 over x, we can write this as 7 times the limit of 1 over x as x approaches positive infinity. So this pattern follows here and also here. And then let us take the respective limits of the expression. And from here, we can see that some limits would be equal to 0. Now, let us take the limits of respective expression. So the limit of negative 4x squared as x approaches positive infinity, we can show that this is negative 4 times positive infinity, and this is squared, plus 7 times 0 all over the limit of a constant 2 as x approaches positive infinity is equal to 2. minus 3 times 0 minus 10 times 0. Let us simplify further. The square of positive infinity will simply positive infinity. 7 times 0 is 0. 3 times 0 is simply 0. And 10 times 0 is 0. Now, this negative 4 multiplied by a positive infinity is negative infinity. All over the denominator is simplified into 2. The negative infinity over positive 2 is simply negative infinity. This is our final answer. Let us copy this answer below problem A. Now let us solve for problem B. We can observe a while ago the functions are similar except that problem B is approaching negative infinity. So we will follow similar pattern of solution. So the first step is to divide each term of the numerator and denominator by the highest power of the denominator. So we have this expression. The next step is to simplify some fractions, and we rewrite the simplified fraction. And from here, we will show the limit of each of the term of the numerator and denominator respectively. The next step is to pull out those constants away from the function, so it will be like this. Next is we can identify those limits that will be equal to 0. Now, let us evaluate the corresponding limits. So we have negative 4 times the square of negative infinity plus 7 times 0 all over 2 minus 3 times 0 minus 10 times 0. The square of negative infinity will be positive infinity. And this is multiplied to negative 4 plus the 0 all over 2 minus 0 minus 0. Simplifying further, we have this negative 4 times positive infinity will give us negative infinity over the denominator 2. And the quotient is negative infinity. Let us copy this answer below problem B. So these are the answers for example 3. I hope you learned something from this video. See you again next time.